Okay, students, in this video, I am going to explain example 1.14 relating functions. Student, this is very important problem, so listen carefully. Check whether the following functions are one to one and on to. They are given some functions, then you have to tell whether they are one to one and on to. So, two problems they given. First problem, f n to n. N to n means natural number to natural number, defined by f of n is equal to n plus 2. Okay, so this is a function they defined. F of n is equal to n plus 2. Now you have to check whether it is 1 to 1 or on to. For those we have to check. Okay, first one. Students, just to recollect what I told for 1 to 1 function. For 1 to 1 functions, if f of x is equal to f of y, then you have to prove x is equal to y. So here they given n. So you should take f of n is equal to f of m. Instead of x, y, take n and m. That's it. So f of n is equal to f of m. So what is f of n? They define n plus 2. So n plus 2 is equal to f of m plus 2. Okay. So these two gets cancelled, becomes n is equal to m. So like we got like x is equal to y, n is equal to m. So f is a 1 to 1 function. Okay. If you want, you can draw the diagram also. This is f 1, 2, 3. Okay. Natural number to natural number. That means domain is natural number 1, 2, 3, 4 dot dot dot, because there is no limit for it. Now codomain also natural number, because function is defined from natural number to natural number. So 1, 2, 3, 4 dot dot dot. For example, if I want one image, f of 1 is equal to 1 plus 2, because n is 1, 3. So 1 is mapped with 3. For example, f of 2, 2 plus 2, 4. Like that you can map. Okay, but 1 to 1 up to this is enough. Okay, for on to, it is better to map the diagram. Then only you will get clear cut idea whether every element in codomain will got the image in domain or not. Okay, students, to prove 1 to 1 it's very easy, that easy. Just f of x or f of I madri, f of n is equal to f of m எடுத்துக்கோங்க. Then you will get n is equal to m. It is on 1 to 1. So if you want to check whether it is onto function or not, it is better to draw the diagram. Okay, so I draw the diagram. Natural numbers domain, codomain also natural number, function. So I mapped some images of some of the elements. One image 3. So 1 is mapped with 3. 2 image 4. Okay. Now they are asking whether it is onto function or not. Clearly it is not onto function. Why? Because you see here, 1 is present in codomain, has no pre-image in domain. Right? What is the definition of onto function? So many number of times I told. For each and every element present in codomain, there should present a pre-image in domain. So இப்போ நீங்கள் 1 அண்ட் எலிமெண்ட்டுக்கு பார்த்தாச்சுன்னா நமக்கு இமேஜே கிடையாது, ப்ரீ இமேஜே கிடையாது. 1 has no pre-image. Even you can write 1 belongs to n in codomain. Like that also you can write. Okay, but in your textbook they given like this. Even you can write like this. 1 belongs to capital N in codomain, has no pre-image in domain. Like that also you can tell. So therefore it is not onto function. So since 1 has no even 2 has a 2 certainly have no pre-image. Okay, at least one reason you should tell. அது wrong and prove பண்ணதுக்கு ஒரு எலிமெண்ட் சொல்லி கொடுத்தா கூட போதும். If you want 2 also you can tell. That is up to you. As 1 has no pre-image, this function is not onto. So this function is not at all onto. Because if it is onto function, every element in codomain should pose pre-image. So if here 1 is there in codomain but there is no pre-image, 2 is there in codomain but there is no pre-image. Okay, so that's why it is not a onto function. Okay, but other elements you may get the images, but 1 to left does not have any pre-image. That's why it is not a onto function. That is the first subdivision, students. Now if you see the second subdivision, f is defined from n union of -1 0. That means for natural numbers you should add -1 0 also. You should include in that set -1 0. So n union, so the full சேர்த்து நமக்கு domain ஆகும். Okay, so n union -1 0 to n. So codomain is only natural number only, defined by f of n is equal to n plus 2. So as usual, first whatever you prove for one-to-one function, same procedure here also, same answer also. Okay, because f of n is equal to f of m, n plus 2 is equal to m plus 2. Okay, f of m, please replace n as m, that's it. So 2 gets cancelled, n is equal to m. So f is a one-to-one function as previous problem. Now second one, see the diagram. Whenever onto means, it's better to draw the diagram so that you can understand very easily. Okay students, here n union minus 1 comma 0 means this is domain, this is codomain. Now you see, for each and every element belongs to n in codomain, there is a pre-image in domain. Okay, because minus 1 image 1, but 1 pre-image minus 1. Suppose if on the minus 1 I took here, what is the answer? F of minus 1 is minus 1 plus 2, that is 1. So minus 1 image 1, 1 pre-image minus 1. Similarly, f of 0 if I take 0 plus 2, nothing but 2. Appo 0 image 2, 2 pre-image 0. You understand? So each and every element belongs to capital N. Eppome onto means you should concentrate on codomain. So for each and every element belongs to n in codomain. Okay, codomain ella element there is a pre-image in domain belongs to. What is the domain? This full set. Okay, so f is a onto function. முன்னாடி உனக்கு அந்த -1 0 கிடையாது. புரியுதா? முன்னாடி செட்ல வந்து there is no -1 0. That's why it is not onto. But here they included. So if you include -1 0, then each and every element in codomain should possess pre-images in domain. You understand student? That's why now it becomes a onto function. But first case it is not onto function. Okay students? So first problem, first to prove one-to-one it is very easy. But onto you should be very careful. Just to draw the function, map some images, then you will come to know whether the codomain is a codomain possess pre-images or not for all the elements. If codomain possess our pre-images, then it is onto. If it does not possess pre-images, it is not onto. So as in the first case, it is not onto. Once you include -1 comma 0, it becomes a onto. Okay students, if you like this video, please subscribe this channel. Okay, bye.